Welcome to The Explainer. Today, we're digging into the story of a sound that once defined the entire soundscape of coastlines all around the world. A deep, two-tone roar that was engineered to slice through the thickest fog and guide sailors safely back to shore.
Okay, so this sounds like the setup to a pretty weird riddle, right? But the answer actually reveals the amazing and surprising origin story of one of the most powerful warning devices ever built. Let's get into it.
All right, before we get to the machine itself, we really need to understand the problem it was designed to solve. For centuries, fog was a sailor's absolute worst nightmare. And the early warning systems they had, things like cannons and bells, they were just dangerously not up to the job.
The whole problem really came down to a simple matter of physics. The high-pitched sound of a bell is made of short sound waves. Just picture these as tiny little ripples hitting a jetty. They just get scattered and broken apart by all the water droplets in the fog. But low-frequency sound, with its really long wavelengths, that acts more like a big ocean swell, just rolling right on through, no problem.
This critical breakthrough didn't come from a scientist in a lab. It came from a Canadian inventor, a guy named Robert Foulis. One super foggy day back in 1835, he was listening to his daughter play the piano, and he realized something incredible. Only the deep bass notes were reaching him clearly. And right then and there, he knew that the key to saving lives at sea was hidden in those low notes.
And this is the perfect way to visualize it. Think of the posts of the jetty as the little water droplets in the fog. See how those big, long ocean swells just roll on by? But the small, choppy surface ripples, they get completely messed up. That is exactly how low-frequency sound can power through obstacles that stop a high-pitched sound dead in its tracks. So, let's circle back to our opening question. What is the connection between a theater and a coastline? Well, it's a musical instrument, the mighty Wurlitzer pipe organ, which was basically the soundtrack for the whole silent movie era.
So, in 1895, an organ designer named Robert Hope Jones had a problem. He needed a bass tone so powerful that it wouldn't get drowned out by the huge orchestra. His solution was something he called the diaphone, a special kind of tone generator that used a vibrating piston to create this incredibly rich harmonic sound.
Well, the potential for this thing went way beyond just music. In 1903, an inventor named John Pell Northey got the rights, totally redesigned it for pure, raw power, and patented it as a fog signal. And by 1914, the first one was roaring on the American coastline. The sound of the sea was never going to be the same again.
So how did this thing actually work? Let's go inside this amazing machine and figure out how it takes simple compressed air and turns it into that legendary, absolutely deafening blast. It's a really clever four-step dance. It all kicks off with a timer, which activates a tiny pilot valve. That then sends a puff of air to open the bigger motor valve. Air rushes in, forcing a piston to start vibrating like crazy. And at the exact same time, that same air pressure forces open this huge speaking valve, releasing a massive charge of air that becomes the horn's incredible blast.
The true genius of this design is right at its core, a lightweight piston with slots in it that literally floats on a cushion of air while it's moving back and forth. This meant there was almost no wear and tear. And get this, it didn't even need super high-pressure air, just a steady supply of about 35 to 40 psi, which was then channeled into two separate chambers to run the motor and create the sound.
And this brings us to its most famous feature, the grunt. When the main air supply gets cut off, the piston slows down, and this last puff of air escapes at a much lower frequency. Now, this wasn't just some weird quirk, it was a critical safety feature. Mariners said that when they were right at the edge of the horn's range, they could often hear that low grunt, even when the main blast was totally lost in the noise and weather.
And the design turned out to be incredibly versatile. The most common one was the Type F. That was the global standard for lighthouses. Then you had the F2T, which got famous for its sustained two-tone B-O sound at major landmarks. And there was even a smaller Type B that companies adapted for fire stations to blast out emergency signals.
So now you've got these incredibly powerful horns all up and down the coastlines. The next big step was creating a standardized system. Mariners had to be able to understand this new acoustic language of the sea, no matter where in the world they were.
So, a set of international regulations, known as COLREGs, created a really clear acoustic hierarchy for ships. And the rule is pretty simple. The bigger your ship, the lower the frequency of your horn has to be, and the farther away it has to be heard. This creates a predictable soundscape out on the water, even when you can't see a thing.
And just to give you a sense of scale, the biggest vessels, we're talking ships over 200 meters long, they have to have a horn that can blast out 143 decibels. That is louder than a jet engine at takeoff. It's a staggeringly powerful sound, and a totally necessary one. And you've got organizations like IALA, the International Association of Lighthouse Authorities, whose whole job is to make sure these navigational aids are consistent all over the world. They're the ones who set the technical standards, defining things like a signal's nominal range, all to ensure safety for every mariner out there.
But that triumphant roar of the Diaphone, well, it started to fade away in the 1960s and 70s. And it wasn't because it stopped working. It was because new, much more efficient technology was just over the horizon.
I mean, diaphones were absolute marvels of engineering, but they were also giant, complex machines that needed constant maintenance. The new electric diaphragm horns, on the other hand, were way cheaper, way simpler, and, this was a huge deal, they could be completely automated with things like laser fog detectors. That meant you didn't need a lighthouse keeper on watch 24/7.
And then, of course, the real revolution happened. Satellite navigation. Things like GPS, combined with radar and AIS, suddenly gave ships the ability to see everything: coastlines, other ships, hazards, electronically, right through the thickest fog imaginable.
This massive technological shift has sparked a really fierce debate that is going on as we speak. Now that almost every vessel has these advanced electronics, are physical aids like buoys and foghorns actually obsolete?
So on one side of the argument, you have the U.S. Coast Guard, for example. They've proposed removing a lot of physical aids. Their thinking is, look, the system was designed before GPS even existed. It's more cost-effective, and it just makes more sense to modernize the system to support the mariners of today who are using electronic charts.
But on the other side, many mariners argue this is a dangerously bad idea. Electronics fail. GPS signals can be disrupted by something as huge and unpredictable as a solar flare. They argue that physical markers are the absolutely essential, reliable backup, the ultimate fail-safe for when all the screens go dark.
So even though it's now largely silent, the Diaphone's legacy is still roaring, and it's living on in heritage sites and in this really crucial debate. It forces us to ask a pretty fundamental question. In an age of silent, precise satellites, what's the real value of a physical voice of warning, a powerful roar to guide us safely home from the sea?
Don't forget to like and subscribe for more How Meets History.